So there's some more notes, and this is what we call the definition of antiderivative. And sometimes this notation can be a little bit confusing, so you just have to kind of always remember the key ideas, and I'll point those out in just a second. Otherwise, sometimes you can get kind of mixed up on these things, so you have to be really careful. A function capital F of x is an antiderivative of a function little f of x if f prime, or the derivative of capital F of x, equals f of x, little f of x, for all x in the domain of f of x. So this is the key idea, that if we take the derivative of the antiderivative, we get the function. So that's the easiest way to check to make sure your notation is straight. The process of finding an antiderivative is called antidifferentiation. Okay, and once you see some examples, you'll get the idea. The notation can be confusing, so we just have to kind of watch out for that. So here's an example. This is little f of x. So we want to find the antiderivative. In other words, we want to find the function that when we take its derivative, we get 2x. Well, from our experience, we could say that capital F of x would be, and then think, what function do we know when we take the derivative, we get 2x? And we have some experience. We know that that would be what? X squared. And all you have to do is check it. If I take the derivative of x squared, what do I get? 2x. But we have to remember that there may be a constant involved because we don't know. It could be x squared plus 2, x squared plus 3, x squared plus 4. If we take the derivative in each case, whatever this constant is, the derivative will be 0, so we'll just have 2x. So we have to add the c. And that's the important part. And then just check it. All you have to do is check it. It's very easy to check it. Since f prime of x equals what? If I take the derivative of this, what do I get? 2x. Which equals f of x. And you see up here, f prime of x equals f of x, f prime of x equals f of x. All right? And these are the problems you'll be doing on your antiderivative worksheet numbers 1 through 24. Okay? All right. Here's another example. F of x equals 1 over 2 times the square root of x. Well, this looks familiar, right? So what function, when we take its derivative, do we get 1 over 2 times the square root of x? It looks like that would be what? The square root of x. But plus c. All right? So comma here, I guess. And if we take the derivative of that, what do we get? 1 over 2 times the square root of x, and the derivative of that is 0. So that works. You can always just check those. All right, let's try another one. Equals 1 over 1 plus x squared. Okay, so this looks like, you go back and look at your formulas, and remember sometimes in class I think we looked at the answers and try to get the questions. Okay, what function is this the derivative of? That's basically all we're working at. We're working backwards. And this is going to be what? The arctan, right? But then again, we also need the plus c. If we take the derivative of the arctan, or the inverse tangent, we get 1 over 1 plus x squared. If we take the derivative of c, we get 0. So there we go. Now we'll also run into some problems where they actually give you the initial conditions and you can find the c. Okay. So here's another example. f of x equals secant squared of x. And we know that pi over 4, comma 3 belongs to the antiderivative. That's what we're looking for. So first of all, we know that f of x equals, and what number has a derivative of the secant squared? Well, we know that it's going to be the tangent, right? That would be the tangent of x plus c. So take the derivative of this. If you take the derivative of the tangent, what do you get? Secant squared. If you take the derivative of c, what do you get? 0. So that works, that checks. That's really easy to check. But we know that since pi 3 belongs to f of x, then we know that capital F of x, we know that f of pi over 4 equals 3. So now what I can do is I can just substitute this in. And every time I see an x, I'll put a pi over 4. And I'll just, every time I see an f of x, I'll put a 3. So we'll just say that f of I can put these in a different color. So this is going to be pi over 4. And this is going to be pi over 4. So every time I see an x, I'll put a pi over 4. Okay, but f of pi over 4 is what? 3. So I can write this as 3 equals. And what's the tangent of pi over 4? That's just 1 plus c. So if I subtract 1 from both sides, I get 2 equals c. So now we can put our c in here. So now we know that f of x equals the tangent of x plus, and c is 2. Oops, what am I doing there? Not c, but 2. And watch out, because I've done that. Somebody told me I did that before on another video, so, or I've done that afterwards on a video, so it may be coming up. So please bear with me if I do that. So c is 2, so put 2 there. Okay. So there you go. So that's an example when we have a, well, we call this like an initial condition. We have a point that's on the curve, we can actually find out what the c is. Otherwise, it could be anything. So we just have to put c there. Depending on what my, if I have a point on the curve, that will help me lock into what the c is. Okay? So there's some examples. And like I said, for the antiderivative worksheet, it's going to be pretty much like examples 1, 2, and 3 for problems numbers 1 through 24.